Hello everyone. We will discuss a problem today called employee free time. So the problem states that for k employees, we are given a list of intervals representing the working hours of each employee. So we need to find if there is a free interval that is common to all employees. It is also stated that we can assume that each list of employee working hours is started on the start time. Okay, so let's look at a couple of examples. So here we have an input list of employee working hours. So it's a nested list. So each internal array here is basically an interval. So we have two intervals for one employee representing his or her working hours, and then we have a second list here, second internal list of two other intervals for second employee. So basically we have to find out if there is a free interval between the working hours of both employees. So in this particular case, if we look at the provided data, we can see that a free time interval is between 3 and 5. So if we look at first employee, he's working between 1 and 3 and then 5 and 6. The second employee is working between 2 and 3 and then 6 and 8. So both of them have free time between 3 and 5. If we look at a second example, here again we have two intervals each for two employees, employee 1 and employee 2, and we need to find out the free time between the working hours provided for both employees. So the answer in this case is between 4 and 6 and then between 8 and 9. So we'll walk through one of these examples here and see how we can actually get to that answer. So this problem broadly falls under the merge interval type of problems. It could also fall under the arrays category. Okay, so we have one approach here. We can call it the naive approach. It's not really that naive, but there is a better approach, and we'll talk about that one as well. But this approach states that we can sort all the intervals between both employees. So if we sort this input array, then we get this array here. So 1 3, we get this array here, 1 3 2 4 6 8 and 9 12. So they are obviously sorted by the start time. Now once we have them sorted, we basically have to walk through the sorted list of intervals, and then we simply find out two intervals that do not overlap, and that would be, and the gap between them would be the free time. So in this case, we can see there is no overlap between 2 4 and 6 8. So clearly 4 6 is a free time interval, and then there is again no overlap between 6 8 and 9 12. So 8 9 is a no overlap interval, which agrees with the answer here. So that is one way to do it. The time complexity in this case would be n log n, because we'd have to sort the input array, and there is possibly a better way to do it. So let's think about that as well. So in the second approach, we will utilize the fact that each internal subarray of work time intervals for each employee, they are already sorted. And remember the statement here, assume each list of employees working hours is sorted on the start time. So as we can see here, this list is sorted by the start time 1, 3, 9, 12, and the second list is also sorted by the start time 2, 4, 6, 8. So we can utilize this, and we will have to use some kind of data structure to keep track of each of these intervals as we walk through them. That data structure would have to make sure that it returns the interval, that it maintains the list of intervals sorted by their start time. So let's really talk about what that really means. So we would essentially have to do a walkthrough for between the two lists, depending on the interval position. So we would look at 1, 3, 2, 4, then we would look at 9, 8, 9, 12, 6, 8, and so forth. So we would need some kind of object that would keep track of some data points here. So those data points would have to be the employee, let's call it employee index. So this could be employee 0, this could be employee 1. Then we would have to keep track of a couple other data points. So we'll have to keep track of obviously the interval. Then we would have to keep track of the interval index. So in this particular case, we have two intervals. This is the 0th one, this is the first one, so we have 0 and 1, similarly 0 and 1. So we will have to use, we can define a class, and we can use that class to maintain those pieces of information. So I have two of these classes set up here. So the interval class represents these intervals. So we have a start and end, and then the constructor takes in start and end. We can set the properties here. And the second class, we can call it the employee interval. So the employee interval would keep track of the interval, the employee index, and the interval index. So the employee index basically would imply whether it's employee 0 or it's employee 1. Then the interval index would keep track of whether it's the first interval for employee 0 or the second interval for employee 0, or the first interval for employee 1 or the second interval for employee 1. And then we would have to write a function which takes this input list of intervals, we're calling it schedule, and then we would have to return a list of intervals that represents the free time for the employees. Okay, so I have CoderPad set up here. So then I have some test cases set up here. So let's start writing some code. So we have a list of intervals here that we're going to return. So remember I mentioned we have to use some kind of data structure to keep track of intervals, and not just keep track in a simplistic manner, but rather keep track of them sorted by their start time. So we can use a priority queue for that. Okay, So this is, remember, the priority queue stores the employee interval object. So we have to do a dot interval dot start. Now I did disable IntelliSense just so we can get a sense of writing code in a Word doc or a simple text editor. Then b dot interval dot start. Now remember, I had mentioned that we will walk through both the lists of employee intervals depending on the position in the internal server. So we'll look at 1 3 2 4 and then look at 9 8 and 9 12 6 8. So we have to populate this queue object. So let's say so we will be adding it'll have to be I, and then we're going to add the first one first. So we'll have to set a 0 here, and then the employee interval object, it's the interval, the employee index, and then the interval index. So the employee index will have to be I. The interval index, because we're adding the first interval only, it'll have to be 0. Okay, and then now we'd have to basically keep track of the previous interval. So the logic is that we will compare, in this particular example, we'll say we compare 1 3 and 2 4, and then we have to look at whether there is an overlap between them or not. So we need a variable that will keep track of the previous interval. And we're going to do that without actually removing the interval from the queue. Okay, and now we're gonna walk through the queue. So at the top, let's look at what's at the top of it. So okay, now here's the important logic here. So pay close attention. So if previous interval, okay, dot end, so if previous interval, say 3 here, is less than top item dot start. So what does that mean? It means there is no overlap. So if the previous, so if this was, say 1 and this was 2, if this was 1, then that would imply that there is no overlap between this interval and this interval. Obviously that's not the case here, but that's the logic we have to code up. So in this case, no overlap, and if there is no overlap, then clearly we have a free interval there, so we have to add that to a result. So I'm just going to copy this here, and then so we're adding a new interval which represents a free interval, and then here's another important point. And then now what we have to do, we set the previous interval to the interval we just removed. To the interval of the item we just removed from the queue. Okay, but in this case, in the else section here, obviously there would be an overlap. So now what would that overlap? So if there is an overlap, what we have to check is so in this case, say 3, the end of the previous interval is less than the end of this current top item interval. So that means we can set the previous interval to be this guy. Previous interval dot n is less than top item dot interval dot end, then previous interval equal to top item dot interval. Okay, now so this is the logic for comparison and finding out the free interval. Now we have to also remember that now we have to keep adding all the subsequent intervals in the internal sub-arrays for each employee. So let's add some code to do that, because initially here we only added the first intervals for each employee. So now we have to take care of the rest of the intervals if there exists any. So so let's get the internal intervals subarray. So we can get that by using the employee index. In this case, in this first loop, employee index is going to be 0. So we will be getting this whole internal subarray here. Now let's think about what we have to do now. So we have to compare the size of this guy with basically we have to check, are there any further items in here? Okay, so maybe it's possible that we may just have a single interval, so we have to have a check if there are any further items in here. So how do we do that? We basically do a if comparison. So interval index for the first go around, it's going to be 0. The size is 2. Obviously 2 is greater than 1, so now we have to add the other intervals to our queue. And our index will have to be the current interval plus 1, or the current interval index plus 1. And then we want to maintain the employee index, so we'll just use that of the top item. And then obviously the interval index will be this guy. And finally we return the result. So these lines of code, all it's doing is it's adding any other interval that exists after the initial first set of intervals for each employee. And we will be doing this every time we go through the loop. So if we say we had more items here after 912 or 68, we would be doing that using these lines of code. So okay, let's run the code and it works. Okay, looks like there's some kind of error. Cannot find item. Oh, I have a typo in here. Stop. Okay, so the answers we just got are 35 for the first one, and 4689 for the second one, and that agrees with the expected answers. Okay, so let's talk about the time and space complexity. So in this solution, for the approach 2, the time complexity would be O of n into log of k. I believe we're using a capital K. Yep. So O of n, because we're walking through the input list of intervals for all employees, but log of k because we are not only iterating through the intervals, but we are also adding and removing items from the priority queue, which has a time complexity of log of k. So the overall time complexity of this algorithm is O of n log of k. And space complexity is O of k because we are not using more than k elements, that is more than k employees as stated, for storing items in the priority queue. So that's it. I mean, this is not a very easy problem to solve. So I'm just going to reiterate the key points here. So the approach one, you can sort the entire array and just walk through it. Time complexity is n log n. So the second approach has a better time complexity. So the second approach, we use the fact that each internal employee schedule is already sorted. So we basically walk through each of them depending on the index of the intervals. That's why we need to use this object called employee interval. And that's it. Thank you for watching. Bye.